Phoenix, Arizona. It's January 10th, 2026, and something extraordinary is about to happen in the conference hall of the 247th meeting of the American Astronomical Society. Andrea Dupree, an astronomer at the Center for Astrophysics at Harvard and Smithsonian, stands up to present the results of 8 years of observations. What she's about to announce will close decades of speculation and open a completely new window into the lives of giant stars. Betelgeuse, the red supergiant that shines in Orion's shoulder, has a companion. This is one of the most important astronomical discoveries of recent years, and I'll explain you why. Let's take a step back. To truly understand what this discovery means, we first need to grasp the real and monstrous nature of Betelgeuse, a star of mind-boggling dimensions. Its radius is about 700 times that of the Sun. Inside the volume occupied by Betelgeuse, you could fit more than 400 million suns. 400 million. You read that right. If Betelgeuse took the Sun's place at the center of the solar system, its surface would extend beyond Jupiter's orbit, which means that Mercury, Venus, Earth, and Mars would all be reached by the heat of the nuclear furnace and literally vaporized. But it's not just about size. Betelgeuse emits about 135,000 times more energy than the Sun. It's a cosmic beacon so powerful that, despite being 650 light-years away, it shines as one of the brightest stars in our night sky. And unlike almost all other stars in the universe, which appear as indistinct points of light even in the most powerful telescopes, Betelgeuse is so big and so close that we can see its surface. It's not a point, it's a disk, a seething sphere of plasma that we can study in detail. Betelgeuse's atmosphere itself is a world apart, so extensive that it could contain the entire inner solar system, so rarefied as to be less dense than the air we breathe, yet the site of phenomena of unimaginable violence. Gigantic convective cells as large as planets, eruptions that expel masses of matter greater than Earth into space, stellar winds blowing at hundreds of miles per second. And it's in this immense turbulent atmosphere that Siwarha orbits, Betelgeuse's newly discovered and named companion. For centuries, astronomers have observed this star with growing puzzlement. Betelgeuse changes. It pulses with a cycle of about 400 days, expanding and contracting like a cosmic heart. But there's also another rhythm, slower, more mysterious, every 6 years or so, precisely every 2100 days. The star shows variations in brightness that no one has been able to explain convincingly for decades. Theories multiplied. Maybe it's gigantic convective cells, or clouds of dust periodically obscuring the star. Magnetic activity? Every explanation had weak points, holes in the logic. But there was a more intriguing, almost romantic hypothesis. What if Betelgeuse had a companion? A smaller, fainter star orbiting so close to the red giant as to be completely invisible, drowned in its blinding glare. In 2024, the first concrete clues arrive. Two independent research teams analyzed more than a century of observations, every photometric datum, every available spectroscopic measurement. They dig through archives, retrieve vintage photographic plates, compare modern measurements with those taken decades ago. And they converge on the same stunning conclusion. The data is compatible with the presence of a companion. Not only that, they even managed to calculate where it should be, what characteristics it should have, and when it should be visible and when, instead, hidden behind Betelgeuse. But actually seeing it is another story. Betelgeuse is about 600,000 times brighter than this hypothetical companion. It's like trying to photograph a firefly 3 feet from the blinding headlights of a car. No, worse, it's like photographing that firefly while the car is coming at you with high beams on. Enjoy deep, fact-checked space stories? Hit subscribe and activate the notification bell. Otherwise, YouTube will not show you the next videos, and you'll miss what we uncover next. July 2025. Steve Howell, a scientist at NASA's Ames Research Center in California, decides to attempt the impossible. He has at his disposal the Gemini North Telescope, one of the optical giants of modern astronomy, located at the summit of Mauna Kea in Hawaii. But above all, he has an extraordinary instrument called Alapake, Fox in Hawaiian, an imager that uses a sophisticated technique to overcome the turbulence of Earth's atmosphere. The idea is simple but brilliant. capture thousands of ultra-brief exposures so fast that the atmosphere doesn't have time to distort the image, and then assemble them together to create a single crystal-clear photograph. On July 21st, Howell announces he's found it, exactly where the models had predicted. There's a faint, luminous source next to Betelgeuse. The companion really exists. It's a spectral type A or B star still in the pre-main sequence phase, young, hot, blue-white in color, which hasn't yet started stable hydrogen fusion in its core. It has a mass of about 1.6 times that of the Sun, but is 6 times magnitude fainter than Betelgeuse in visible light. 6 magnitudes means Betelgeuse is about 250 times brighter in the visible spectrum, but considering all wavelengths, the difference is even more dramatic. Howell and his team immediately decided to give it a name, and they chose it carefully. Betelgeuse comes from the Arabic Yad al-Jawza, meaning the hand of Al-Jawza, a female figure from ancient Arabian mythology. So they proposed Siwarha from the Arabic Siwar, meaning the bracelet, the hand and its bracelet, a name that was officially recognized on September 22, 2025 by the International Astronomical Union Working Group on Star Names. And here's the key point of the whole story, what makes everything incredible. The distance of 600 million kilometers, about 370 million miles, places the newcomer actually inside Betelgeuse's outer atmosphere. Siwarha, in short, doesn't simply orbit around the red giant, but is literally passing through, plunging into the incandescent gas, carving a path through that cosmic fog every time it completes its revolution. But it's what happens 5 months later in January of 2026 that takes everything to a completely new level. Dupree and her team have spent almost 8 years collecting data, not with just any telescope, with Hubble, the legendary space telescope, and with a series of top-tier ground-based telescopes. They've pointed their instruments at Betelgeuse again and again, collecting ultra-high-resolution spectra, measuring the subtlest variations in the ultraviolet light emitted by ionized iron in the star's atmosphere. And they saw something extraordinary. When Siwarha is in front of Betelgeuse from our vantage point, the spectrum shows an intense peak of blue-shifted light. But when the companion has just passed and is behind the supergiant, that peak weakens drastically, as if something is absorbing it. What's happening? As Siwarha crosses through Betelgeuse's atmosphere, it creates a wake of dense gas. Just like a bullet passing through water leaves behind a cavity, a turbulent structure, the companion star disturbs the gas it's passing through, compressing it, heating it, creating a trail that persists for weeks after its passage. This wake absorbs part of the ultraviolet radiation from ionized iron, modifying the spectrum we observe from Earth. It's the unmistakable, unequivocal signature of the companion's passage through the giant's atmosphere. For the first time, we're seeing clear signs of this wake of gas, Dupree announces during the Phoenix conference. The room is electrified. She pauses, lets the words settle. Proof that Betelgeuse really does have a hidden companion that shapes its appearance and behavior. Suddenly, puzzle pieces that seem not to fit start finding their place. The Great Dimming of 2019-2020, that event that made headlines worldwide, when Betelgeuse lost more than 2/3 of its normal brightness in just a few months. At the time, people talked about an imminent supernova, about the red giant's impending end. Then it turned out it had been a gigantic mass ejection. The star had erupted a colossal amount of hot gas, which, cooling in space, had formed a dust cloud more than 180 million kilometers, about 110 million miles across, partially obscuring the stellar surface. But why do these events occur? Siwarha's presence offers new, fascinating answers. The tidal forces exerted by the companion on Betelgeuse's turbulent atmosphere could trigger or amplify the instabilities that lead to these dramatic mass ejections. The 6-year cycle coincides perfectly with the companion's orbital period. It's no coincidence. Siwarha doesn't just periodically sweep away the dust surrounding Betelgeuse, making it appear brighter when it passes through certain zones of its orbit. Its very presence, its repeated passage through that immense and turbulent atmosphere, modulates the dynamics of the entire system, creates accumulations of dust here, dispersions there, perhaps triggers eruptions that wouldn't otherwise occur. And there's another implication, perhaps less spectacular but scientifically crucial. Betelgeuse won't explode tomorrow. After the Great Dimming, many wondered if the star was about to explode as a supernova. The answer is now clear: no. Many of the phenomena that seem to indicate terminal instability were instead effects of interaction with the companion. The most recent analyses confirm that Betelgeuse is still in the thick of the helium fusion phase in its core, a phase that, for a star of this mass, lasts about 1.2 million years. Even in the most pessimistic estimates, several 100,000 years remain before the final explosion. The chances of witnessing Betelgeuse's supernova during our lifetime? Less than 0.1%. The explosion will happen, certainly. One day in a few 100,000 years, or maybe even a few million, Betelgeuse will run out of fuel. In a fraction of a second, the core will implode under its own weight, then rebound in an explosion so violent as to briefly eclipse an entire galaxy. A Type 2 supernova, an event so energetic that for weeks it will shine in our sky like a crescent moon, visible even during the day. But that moment is still far off. And Siwarha, its story is destined for a tragic end on cosmic timescales, though brief for a star. Betelgeuse and its companion probably formed together about 10 million years ago from the same cloud of gas and dust collapsing in interstellar space. But while Betelgeuse, massive and fuel-hungry, burned rapidly through its reserves and is already in its terminal phase, Siwarha is still trying to ignite stable hydrogen fusion. It may never get there. Tidal forces are dragging it ever closer to the red giant. Scientists estimate that within the next 10,000 years, Siwarha will be swallowed by Betelgeuse, merged with the Colossus, gone forever, long before the supergiant explodes. Right now, from our terrestrial vantage point, Betelgeuse is eclipsing its companion. Siwarha is behind it, invisible, hidden in the giant's glare. But in 2027, it will return to its maximum angular separation, and that will be a new precious opportunity. Astronomers are already planning observing campaigns with all the world's major telescopes. Hubble, obviously, but also the ground-based giants, the Very Large Telescope in Chile, the Keck telescopes in Hawaii, perhaps even the James Webb Space Telescope. With this direct evidence, Dupree continues, Betelgeuse offers us a front-row seat to watch how a giant star changes over time. Identifying the companion's wake helps us better understand how these stars lose mass and move toward their final explosion. And there's more. About a third of cold giant stars show long, mysterious variation cycles similar to those of Betelgeuse. How many of these hide undetected stellar companions? If Betelgeuse, one of the most studied and monitored stars in the sky, kept this secret hidden for millennia, how many other extreme binary stars are we missing? The discovery could revolutionize our understanding of stellar evolution in its final phases. For millennia, Betelgeuse has shone in the celestial hunter's shoulder, a symbol of cosmic power, the subject of myths and legends in cultures around the world. The ancient Egyptians associated with Osiris. The Chinese called it the star of the supreme general. The Arabs gave it the name we still use today, the Hand of Al-Jawza, a female figure from their mythology. And now the name has found a companion, Siwarha, her bracelet, as they've proposed calling the companion star. That millennial solitude was only apparent, hidden in the supergiant's blinding glare. Siwarha has always danced its mortal orbit, plowing through an atmosphere as vast as a planetary system, leaving behind a wake that only now, with 21st century technology, we finally managed to see. It's one of those discoveries that remind you why astronomy matters. Not because it tells us something immediately useful for daily life, but because it shows us that the universe is richer, more complex, more wonderful than we could ever have imagined. Stars we've observed for thousands of years can still surprise us. Mysteries that seem destined to remain forever unsolved suddenly open up before our eyes. And when hundreds of thousands of years from now, Betelgeuse finally lights up the skies in an explosion that will make the sun look like a candle by comparison, Siwarha will already be gone, merged with its giant companion in one last fatal embrace. But for now, this cosmic couple continues its ancient dance, offering us a privileged window into the processes that govern the life and death of the universe's most massive stars. Recently, we made another unexpected discovery, this time about Jupiter. Check out our video dedicated to it to learn more.